What's up, everybody? It's Hutch here, and this is your Module 13, Lesson 2 video on reflections. Remember, these are transformations, sort of like transformers. And we did translations last time, which is a slide. Okay. We have a pre-image, which changes to an image or new image. We also have the notation that shows how to translate or transform the image, and that is called mapping. Okay, you might see coordinate notation, but the official term that I want you to use is mapping. Okay, so let's go ahead and take a look here. Also in the symbols part here, let's go ahead and label this as mapping. Okay, or sometimes, remember, you might see coordinate notation. Okay, it's a way to show how to create the new image from the pre-image. Okay, so let's go ahead and slide down to today's lesson on reflections. We're going to watch the Math Shorts video by clicking on the image below. If you're watching this with me, you can just follow along. Let's take a look at our blanks today. When you look into a mirror, your reflection appears to, let's add in B, to be the blank distance from the mirror as you are. Pretty sure that's probably the word same. Next one, when looking into a mirror, notice how the left and right sides are and blank. We might have to wait and see what that one is. Okay. And then on a coordinate plane, the mirror is actually a horizontal, vertical, or diagonal blank. Let's wait on that one too. If a shape is reflected correctly, each point of reflection will be the blank distance from the line as the original shape. Pretty sure we can commit to the word same on that one again. And the reflected shape is the blank size and shape. Same size and shape. It is congruent and similar. All right, let's go ahead and take a look at the video here. Okay, so we're clicking the image. It takes us to this YouTube video, and let's check it out.
Math Shorts.
Reflection is a type of movement or change in a geometric shape. Think about when you look in a mirror. You see a reflection of yourself. See how your reflection appears to be the same distance from the surface of the mirror as you are? Also note how the left and right sides are reversed. The same is true with geometric shapes.
Okay, so let's go ahead and fill out reversed. The left and right sides are reversed. Okay, back to the video.
When we reflect this triangle like this, the x-axis acts like a mirror. You can reflect all kinds of shapes as long as you determine the line that you want to reflect on, just like a mirror. For example, you can use any line along the x-axis or the y-axis. You can even reflect a shape through a line using an expression such as x equals 1. In this example, the line x equals 1 is the line of reflection for the two triangles. You can use any expression to create a line of reflection anywhere. The way to make sure a shape is correctly reflected is to check that each point of one shape is the same distance from the line of reflection as the corresponding point in the other shape, and that it has corresponding sides and corresponding angles. Just like other transformations, you can record the coordinates of the shape and its image to demonstrate the reflection too. Reflection makes a mirror image. It's one type of movement for geometric shapes.
All right, so that's it for that. Let's head back here. Our last one here was on a coordinate plane. Make sure you adjust the spelling of coordinate, coordinate. The mirror is actually a horizontal, vertical, or diagonal, and that was line. Okay, so they showed that you can reflect over any of those lines that are stated, whether it's an x-axis, y-axis, a line on the x-axis, or even a diagonal line. So reflection, what I want you to highlight is the FL, okay? And the hint for this is going to be a flip, F-L-I-P, okay? All right, let's go ahead and try it out. It just says describe the line of reflection, okay? And so if we're describing the line of reflection, we would say it reflects over which axis, okay? So let's go ahead and write reflects over the x-axis. And you can see that it does that because if you count them, we can see from the x-axis we have 1, 2, 3, and we have 1, 2, 3. So it's flipping over the x-axis. Okay, let's go ahead and take a look at the next example. What's it flipping over? You can see it's the same distance from this point here. We have a distance of 3 from each side, and so it is reflecting over the what? In this case, it's the y-axis. Okay, and then the third one, what is it reflecting over? Okay, you can see that it's 1 away from this point, 1 away from this point. So in this case, it's not really reflecting over the x-axis itself. Okay, it's reflecting over this line, and you have to describe where the line is crossing, and it's crossing at this location where y equals 2. Okay, and so we have this line of y equals 2, so we'll say reflection over y equals 2. Okay, so we're just describing what we're reflecting across or over. Okay, all right, now let's go ahead and get a little bit more specific here. Here we have a graph of triangle ABC, and they're asking us to graph the image, which we know means new image. So just don't forget that. We're using the language of pre-image and image. Okay, after reflecting across the x-axis. Okay, write the coordinates of the image or new image. So our just trick to make this happen right away would be to count the same distance. We're crossing over the x-axis, so let's go ahead and start by just showing our line and emphasizing that. Okay, so there's our x-axis. I have 1 away there and 1 away here. So this point here is going to be what we remember call C prime. Okay, how far is B from the x-axis? We are 1, 2, 3 away. 1, 2, 3 away. So here's B, but we're calling that B prime. And then A from the x-axis is 2 away. So we're going to go 2 away on the other side of the x-axis, put our point. Okay, that's important. And this is our A prime. Now we can go ahead and change colors and connect those points. So I'm going to hard press here, and then I can have nice crisp connections. Hard press, make the line, nice and easy to connect. Hard press, make the line, and then nice and easy to connect. So you can see the reflection like a mirror over that x-axis. Okay. Now, it says write the coordinates of the new image. And so on the side here, we need to go ahead and write those new coordinates. Okay, so let's go ahead and I actually want you to see what's happening between pre-image and new image. Okay, so let's go ahead and write C and write its ordered pairs. So C is -1 and +1, x and y. And when we do the mapping here, okay, and showing what the new image ordered pairs are, we can say C prime. And then I want you to take a look at what this is for C prime. It's still -1. Okay, so when we reflected on the x, look what didn't change. Okay, but it's -1 and then it goes -1. So if I just ask you to pause and think about what changed and what didn't change, okay, we can see that our x's didn't change at all, but our y's, there's one slight change when crossing over the x-axis. Okay, all right, let's do our next one. So we have B, and it was ordered pair 1 and then up 1, 2, 3. And we reflected to B prime of still +1. So again, we're seeing this continued pattern of the x isn't changing, okay? But now we are -3. So did the same pattern occur? All right, and then we have A, ordered pairs are 1, 2, 3, 4, 5, 2. And how did it reflect? It's still 5, so A prime is 5, but now it's -2. So what stayed the same throughout? You can see x stayed the same, okay, but y changed the sign. Okay, so here's a little song I want you to sing. It goes to Mary Had a Little Lamb, okay, and it says, reflect across the x stays the same. Reflect across the x stays the same. Reflect across the x. That's not Mary Had a Little Lamb. Mary had a little lamb. Reflect across the x. X stays the same. Stays the same. Reflect across the x. X stays the same. But y must change its sign. That didn't go very well. But you can laugh at home without me hearing it, which will make me feel better. You got the idea. Obviously, I couldn't do that very well. All right, so when you're reflecting across the x, x stays the same, but y must change its sign. So let's go ahead and take a look at this next one on the right. Okay, it says to graph the coordinates of triangle PQR. So they're giving you those coordinates. So let's go ahead and do that first. So point P is 1, 5. So over 1, up 5. Babies crawl, then they learn to stand or fall. So 1, 1, 2, 3, 4, 5. So right here, here's P. Then we need Q is 3, 7. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. So here's Q. And then R is 4, -1. 1, 2, 3, 4, -1. So here's R. Okay, let's go ahead and connect our points. Or a nice hard press there. We'll lock that in. And there we go. So here's PQR. We're going to graph the image after reflection across the y-axis this time, and then write the coordinates of the reflective image. Okay, so since we're going across the y, let's go ahead and show the line we're reflecting across. This is sort of like our mirror. Okay, still has the arrows here though. And so we know that we're going to take the P, and it is 1 away from the line, so we're going to cross the line, and this is P prime. Q is 1, 2, 3 away from the line, and so we're going to go 1, 2, 3, and plot Q. But this is Q prime. R is 1, 2, 3, 4 away from the line, so we're going to go 1, 2, 3, 4 over the line this way and put R prime. Now we can go ahead and connect the points. And this is how you do a reflection. Okay, we do need to write the coordinates of the reflected image. Okay, so let's do the same thing we did. This is something you could try on your own. Now this time we're reflecting across the y-axis. So this is the only thing different. Let's sort of see what happens. Okay, so I'm going to start with P, and original ordered pairs for P were 1, 5. And what happened to 1, 5. So let's go ahead and label our x and our y here so we can see what's going on here. So now we're at -1, but we're still up 5. So do you see what happened when we crossed the y-axis? What's staying the same? What's changing? Okay, now we have, oops, and I forgot to put my P prime here. So let's shift this over a little bit. And we need to make sure that we're accurately notating that. All right, so let's go ahead and do Q now. So Q originally, we can just look up at the top here, was 3, 7. And we are reflecting it to Q prime, which is -3 now, but still +7. So what's changing? What's staying the same? Okay, and then our last one was R. It was 4, -1. And when we reflect to R prime, we end up with -4 and still -1. Okay, so if we look at our x and y's, when we cross the y-axis, what do you notice is staying the same? Well, the thing staying the same this time is our y's are staying the same. Okay, so what can you say? Can you draw a conclusion about that? When we reflect over the x, what stays the same? When you reflect over the y, what stays the same? And also maybe can you identify what happens to the other coordinate, okay? So here's the rest of your song. I still can't guarantee that I'm going to sing it right. Okay, Mary had a little lamb. That's the song, right? Okay. Reflect across the y stays the same, stays the same, stays the same. Reflect across the y stays the same, but x must change its sign. So basically, reflect across the x stays the same. Reflect across the y stays the same. So this is what we're remembering for reflections. Okay, let's head down to the next section here and see what we have. Okay, so this section here, they're telling us to graph the coordinates of PQR. Great one for you to just try out on your own, because then it says then graph the image after reflection across the y-axis. So sort of like a try it out on your own thing. Okay, you can do it and then check or follow along with me. Okay, so I'm going to go ahead and do PQR here. P is 1, 5. Oh, maybe that's why it's crossed out. It's the exact same thing, figures. All right, we don't need to do that twice. Go ahead and cross that out, and we'll head to the next problem. All right, let's go ahead and try this one out. Again, this would be a good one for you to try out on your own if you want, or you can follow along. So here we go. Graph the coordinates of triangle EFG. So let's go ahead and do that. So over 2, up 4, 1, 2, 1, 2, 3, 4. Okay, and we're going to label this E. Point F is 0, -2. So we stay at 0 and then just go down -2. And that's point F. And then G is -3, 2. So 1, 2, 3, and then up 2. And here's our G. Let's go ahead and connect to those points and make our triangle EFG. It's like the BFG, that movie or that old book by Roald Dahl. All right. Then graph the image after reflection. Now here's what we need to pay attention to. Across the line x equals 3. So let's make the line of x equals 3. Okay, so go over 1, 2, 3. Here's the line of x equals 3. So we're going to generate that line. Okay, I'm going to call it what it is, x equals 3. Okay, so we formed a line where x equals 3. Okay, so let's go ahead and make the reflection over that line now. Okay, so let's check it out here. Did I do that right? 2, 4, 0, -2. Oops, my last one, G, was -3, 2. I wonder, did you catch that? Because I didn't catch that. Okay, so last one was G is -3. I went +3. 1, 2, 3, and then up 2. So this is where G is. As you can see, it's not like this is like crazy hard, but you still got to be really careful and make sure you're following the ordered pairs correctly. If you caught that on your own, nicely done. You are a superstar. I didn't mess up. It was just a test, and you passed. All right, sure. Let's go ahead and do the reflection now. So we're going to reflect, but this time we're reflecting across where x equals 3. So we're looking at the distance, and we're going the same distance on the other side for each point. So I have E prime. We can look here, 1, 2, 3, 1, 2, 3. Here's F prime. And then G is 1, 2, 3, 4, 5, 6 across. 1, 2, 3, 4, 5, 6 across. Okay, and so there's my G prime, and I can go ahead and connect the points. So there's 1, here's 2, and final one should snap right into place. There we go. All right, and so you can see that reflection right over x equals 3. Let's go ahead and record down our new ordered pairs. So I'm going to go in order that they told us up there. So EFG, that way I can write what it says, so I don't have to really think about it too much. So E was 2, 4. We could even continue down here. F was 0, -2. And then G was -3, 2. Okay, and then we can go ahead and draw our lines to show our new image coordinates, okay? And now here we go, okay? So what is E now? Okay, E is 1, 2, 3, 4, and 1, 2, 3, 4. So E prime is ordered pair 4, 4, okay? Let's go ahead and look at F. F is now 1, 2, 3, 4, 5, 6, and negative 2. Okay, so we have 6 and, oops, whoa, where am I writing that? Jeez. Okay, so F prime is 6 and negative 2. And then our last one is G prime, and it is, and let's start looking at the pattern again. Okay, we're still crossing over an X, okay, or technically we're crossing over a Y type axis. It's just where X equals 3. So it's still behaving like crossing over a Y. And one of the things we said is when we're crossing over a Y axis, okay, that Y stays the same. And if you look at all of these, okay, we have our XYs, okay, so here's our Y, here our Y. If you look down that, all the Y's are exactly the same. We have 4 and negative 2, 2, we have 4 and negative 2, and so we can right away figure out what the other one is, okay. Now we're not just flipping the sign though, for the X for these ones, because we're not actually flipping on the Y axis. And so because we're flipping over a different value, that one's a little bit different. So just be aware of that, okay? All right. So let's go ahead and calculate our new ordered pair for G prime. We're over 1, 2, 3, 4, 5, 6, 7, 8, 9, and up 2. So 9, and we're still up 2 because the Y doesn't change. Okay, so there's our new points for that, and we can go ahead and move on to the next one. Okay, all right, let's go ahead and take a look at some more examples here and practice using some of that notation. So one of the things that we want to do is take a look at a reflection across the x-axis. We know that when you reflect across X, X stays the same. When you reflect across Y, Y stays the same, okay? And then you just change the other one's sign, okay? So you can see what it says. It says the X coordinates are the same. The image's Y coordinates are opposites of those of the pre-image, okay? And so they give us the symbols here. And remember, we're calling this mapping. Okay, same thing over here. When we are crossing over the y-axis, y stays the same. Okay, and again, let's write that this is called mapping. Okay, all right. So when you're taking a look at something like that, that's something I want you to be aware of right away. Okay, so let's highlight a couple things here. Here we have reflect across the X, okay? So let's write reflect. That's not how you spell that. Reflect across X, comma, X stays the same, okay? And then over here, we have reflect across Y, comma, Y stays the same. So something to be aware of, okay? And then we have some practice problems right here to take a look at, okay? So triangle RST has those coordinates. The triangle is reflected across the x-axis, okay? So across the x-axis, what stays the same? Let's write that right now. X stays the same, okay? So let's go ahead. It tells us to write the coordinate notation, or remember that's also officially called write the mapping for a reflection across the x-axis. Then write the coordinates of the image. Okay, so we got to do two things here. The first thing is the mapping. So that's sort of like the rule, remember? So what are we doing? We're taking the x and the y, and we draw the arrow. And what are we doing with every x and y? Okay, remember x stays the same. And then what happens to the y? Y changes its sign. So that's the rule for every single ordered pair when we're crossing the x-axis. Okay, now let's write the new ordered pairs. We don't even need to draw it out because we have this rule, right? Okay, so we have r, which happens to be 2 is x, 1 is y. What happens? Well, r prime turns into 2, negative 1. Okay, what happens with s? Well, we have s originally was negative 1, 3. And what's s prime going to be? Well, when we reflect across the x stays the same, so negative 1. And what happens? We flip the other one sign, so we have a negative 3. Okay, then we have your t, negative 2, 0. What's going to happen with the reflection? T prime is going to x, when you reflect over the x stays the same, so negative 2. And then we flip the sign. Now 0, negative 0, still 0. Okay, so there we go. Okay, so without even drawing it, because of understanding that pattern, we can just write it. Okay, let's take a look at this one. It says triangle RST has those coordinates, and it's reflected across the y-axis. Okay, so what do you know? Reflect across the y stays the same. Okay, all right, so write the coordinate notation for the reflection across the y-axis and the coordinates of the new image. Okay, so remember coordinate notation, our official name we're using is mapping, okay, which is just the rule. So what's the rule? Well, it means we're going to take x and y, and what are we going to do to x and y? Well, across the y-axis, what stays the same? Y stays the same. What happens to x? We change its sign. So that's what's happening here. Let's go ahead and do it now. Okay, so we have r originally was 2, 1. And what happens to it? Well, r prime, we flip the sign of x, so we have negative 2. And what happens with y? Y stays the same. And what was y? It was just 1. Okay, let's go and do the next one, which is s. S was negative 1, 3. Reflecting over the y stays the same. So s prime, I know the y stays the same, and the x changes its sign, so it's now positive. And the last one we have is t. T is negative 2, 0. So what's t prime? Well, reflect across the y stays the same. And so we have y staying the same at 0, x changes its sign, so we have positive 2. So there we go, that's how you do it. Okay. The last one for today says the coordinates of triangle EFG and its image are shown below. Just describe the transformation using words. Okay, so what's happening based on what you see here? So what do we need to analyze? We just need to analyze what's staying the same. Okay, now you do have to take a peek at the other coordinate just to make sure that it's not reflecting over some weird line on the x or y axis. So let's go ahead and just do some analysis here. Here's our x, here's my y, here's my x, here's my y. Okay, which one's staying the same? If you look through, 4, 4, 2, 2, 5, 5. Okay, so x is the same. So what does that mean we're reflecting over? Okay, we're reflecting over the x-axis because x is staying the same. Okay, take a look at the y. What's happening to the y? Well, 5, negative 5, 2, negative 2, 1, negative 1. So we're truly reflecting just over the x-axis. Okay, not over some line where y equals something. Okay, so there you go. That's all the little pieces of reflection. The only thing we didn't really practice or talk about is a reflection across a diagonal, but you can understand the same idea. If it was reflecting over a diagonal line, you could just do what they showed you in the video, okay? But that might be probably is something you probably won't run into, and if you do, you'll be able to just sort of map it out on the ordered pair or on the coordinate grid. All right, if you have any questions, let me know, but that is it for reflections.